Every day, your hands execute a massive range of mechanical tasks. One minute, they're locking in a crushing grip around a heavy barbell, and the very next, they are striking 50 different keys a minute to fire off a text message. These digits instantly react to our intentions, performing thousands of microscopic spatial calculations and physical corrections without a single conscious thought on your end. Because we can literally see the fingers doing all this heavy lifting, it makes logical sense to assume they operate exactly like our biceps or our calves. Our intuition dictates that if a joint is bending with that much force, the biological engine driving it has to be packed right there under the skin, at the exact site of the movement. But when we actually strip away the skin and look at the internal anatomy, we find a biological impossibility. Your fingers contain zero muscle tissue, none at all. If the local mechanical engines required for movement are completely missing from the digits, how exactly are you generating 50 pounds of grip force? To solve this, we have to ignore the rest of the hand for a moment and isolate the skeletal framework of a single digit. This diagram shows a chain of 3 delicate, highly articulated bones known as the phalanges. They are arranged in a strict sequence: the proximal base, the middle joint, and the distal bone right at the fingertip. But bones are just dead weight. On their own, these perfectly aligned phalanges are nothing more than an inert system of mechanical levers. They are completely useless without an external force pulling on them. To find the actual power supply, we have to travel away from the hand entirely, moving up through the wrist and into the arm. This wide schematic reveals that the heavy, powerful engines responsible for closing and opening your fingers are actually packed tightly within the forearm. The muscles bridge the physical distance using high-tensile cords called tendons. It operates as a dual-action setup. Flexor tendons run along the palm side, pulling hard to close the grip, while extensor tendons run along the back of the hand, pulling in the opposite direction to open it back up. Your fingers operate as biological puppets, driven entirely by an elegant remote control cable system powered by massive motors located a foot away. But remote cable systems suffer from a serious mechanical flaw. If you run a straight wire across a bending joint and pull it tight, the wire will naturally take the shortest path and physically detach from the inside curve. Without a countermeasure, this bowstringing effect would cause tendons to snap violently outward under the skin during a fist. Biology solves this using annular pulleys, tough ligaments that staple cables flat against the bone, strictly following the contour of the bend. However, trapping a moving, high-tension cable tight against a hard piece of bone creates a massive friction problem. Left unchecked, that friction would shred the tendon in a matter of hours. To counter this, the entire biological cable is encased inside a synovial sheath, a flexible tube filled with lubricating fluid that drops the friction coefficient down to near zero. This specific combination of locking pulleys and fluid sheaths is the sole reason our hands don't tear themselves apart under heavy physical strain. Which brings us to the ultimate question: why go through the trouble of evolving such a complex remote control setup instead of simply building local muscles directly into the fingers? It comes down to a strict engineering trade-off between power and size. Generating the crushing force required for a human grip demands significant, bulky muscle mass. This comparative silhouette shows the physical reality. If those massive power-generating muscles were housed directly inside your fingers, your hands would be impossibly thick, clumsy, and entirely useless for fine motor skills. Relocating those heavy motors to the forearm is the ultimate biological compromise. It grants the fingers the extreme slenderness required to thread a needle, without sacrificing the brute grip strength needed to lift your own body weight. Your hands operate as highly engineered machines, relying on a sophisticated network of mechanical levers, remote cables, and frictionless pulleys to interact with the world. And this entire system executes flawlessly, thousands of times a day, operating completely under your conscious radar. If you want to continue exploring the hidden mechanics of the human body, make sure to subscribe to BioMotion 3D, because the most extraordinary feats of engineering on Earth are already operating continuously, hidden just beneath your skin.